Hi, Year 11. Here's a little video to help you review theorems. It's one of the topics that was requested to go through. So I'm going to go through each of the rules and do a little practice question for each one. Okay, so here's the first one. Angles from the same chord are equal. Okay, so that is the reason. And all you're going to remember is you're looking for a bow tie situation. So if we remember, this is a chord. And this angle is extended from the chord, but so is this. So because those angles are from the same chord, that means these angles will be the same. And it's equally true that you've got it the other side. So from a different chord, but the angles are from the same chord, so they will be equal to each other. So basically the tips of the bow tie are equal to each other. The angles are equal to each other. So look out for that. Look out for bow ties. So, you know, should be nice and easy. We can say that P is equal to 27 degrees because it's equal to the other tip of the bow tie, and Q is equal to 29 degrees for the same reason. And then don't forget that all your other rules of angles still apply. So we can find angle R. Well, that's just angle sum of a triangle. It's going to be 180 degrees minus 27 degrees minus 29 degrees, which is what? 27 plus 29 is 56. So what's that? 124 degrees for R. Don't forget, you need to be able to give the reasons. Angle P is 27 degrees because angles from the same chord are equal. Q is 29 degrees because angles from the same chord are equal. R is equal to 124 degrees because there are 180 degrees is the interior sum of angles in a triangle. Okay, make sure you give the reasons. Okay, here's rule number 2. The angle at the center is twice the size of the angle at the circumference. And hint, we need to look for an arrow. Okay, we need to look for an arrow. So here we've got an arrow situation. So all that means is the angle at the center is going to be double angle at the edge. But don't forget, it's not always a nice arrow. Sometimes it's more like a bow tie. So let's have a look here. Like this situation here, that looks like a bow tie. It's not a bow tie because this point here is not at the circumference, it's at the center. So if you've got a bow tie where one of the corners of the bow tie is at the center, actually it's an arrow. So again, what we would know is that this angle here is half this angle here. Okay, very, very, very important. You sometimes even get a crazy one where, you know, maybe you've got an angle here, okay, and then you've got an angle here. So this angle and this angle. Well, weirdly enough, that is actually also an arrow. I know it doesn't look like it. And all that would mean is that this angle here would be double this angle here. Okay, so the consistency of it is still there. So don't forget, though you're looking for an arrow, well, this is an arrow. Okay, it's been sort of warped, and this is also an arrow, even though it doesn't look like an arrow at all. Okay, it means this angle here will be double this angle here. Okay, so let's use it. It's nice and easy. Calculate angles A and B. Well, very easy. A is equal to 61 degrees, and so is B equal to 61 degrees for exactly the same reason. They're both half the angle at the center. Okay, because you've got two arrows there, so A and B are equal to each other. And of course, hopefully it makes sense that A and B are equal to each other, because in that picture you've also got a bow tie. So it would make sense that A and B would be the same. Okay, The angles in a semicircle is always a right angle. Okay, so if you got a line that is the diameter, okay, so it's not a chord, it's a diameter. I mean, diameter is a kind of chord, but specifically it's the diameter. Then we make any angle from that chord, from that diameter, it's going to be 90 degrees. So even if I do it like this, then that angle is going to be 90 degrees, okay? So let's use that here. Where's that come from? Whoops, sorry about that. So we need to find these missing angles. So what can we find out? Well, W, I think we could say is 15 degrees because angles from the same chord are equal. Okay, you basically got two angles coming from this same chord here. X is equal to 90 degrees. How do we know? Well, actually, I'm making an assumption, but it's a correct assumption that AD is the diameter. And therefore, what we've got here is a semicircle situation. So a semicircle always makes a right angle. Okay, so angle X must be 90 degrees, which means we can find Y. Y should be easy enough. It's just going to be 180 minus 90 minus 15, which is 75 degrees, because angles in a triangle sum to 180. So basically, I'm looking at this triangle here. And then it will be easy to know Z, because it's going to be 180 minus 75 degrees, which is 105 degrees, because there are 180 degrees in a straight line. So I'm sort of looking at this straight line here. Okay, this angle and this angle must add to 180. So don't forget your normal rules as well when you're doing a circle theorems question. Okay, all your rules of angles will come into play. And all you really do is go around finding as many angles as you possibly can until you find the angle that you're interested in. Okay, rule 4. Opposite angles in a cyclic quadrilateral add to 180 degrees. Now, cyclic quadrilateral must have all four corners on the circumference. For example, if you have this, that is not a cyclic quadrilateral because this point is not on the circumference of the circle, okay? So make sure that you're actually dealing with a cyclic quadrilateral, and then we know this plus this is equal to 180, and this plus this is also equal to 180. So let's use it. Calculate A. A should be easy. That's going to be 68 degrees because angles on a straight line add up to 180. We know that B is going to be equal to 112 degrees because this angle plus this angle must be equal to 180 because it's a cyclic quadrilateral. And C must be 180 minus 93, which is 87 degrees, for the same reason. Opposite angles in a cyclic quadrilateral sum to 180 degrees. Okay? When a tangent meets a radius at the circumference, we get a right angle. Okay? So here is a radius. If it meets a tangent at the circumference, then we get a 90-degree angle. Get a right angle. Okay, so look for those T's. This kind of situation is no good. That's not 90 degrees because the point at which they meet is not on the circumference. It must be the point on the circumference where they meet to make a 90-degree angle. Okay, so let's have a look here. Calculate X and Y and show your working. Well, X should be equal to 52 degrees simply because this is a right angle. So if I didn't show my working, so it should be 90 minus 38, which is equal to 52 degrees because when a tangent meets a radius, we get a 90-degree angle. Okay, so we know X. Now, how are we going to find Y? Well, there might be a few ways of doing this, but let's just change colour to red. One way of doing it is, let's find out what this angle is. Well, that angle must be 19 degrees, because again, this must be a right angle, okay? Which means this entire angle is 38 plus 19, which is 57 degrees. Now we've got a triangle here, okay? So I can know this angle must be 180 minus 57 minus 48, so that's that angle and that angle taken away from 180. So what would that be? 57 plus 48, 105. So that's going to be 75 degrees. So that angle is 75 degrees. And now I've got another triangle. Let's just change colour so we can see it. Let's go for green. Where we know two of the angles in there. So it's going to be 180 minus 75 minus the 38. Oops, about that. This 38 here. Which is going to be equal to 105 minus 40 is 65 plus 2, 67 degrees. Okay? Rule 6. Two different tangents coming from the same point are of equal length. So here is a point. If I make a tangent to the line in this way and a tangent to the line in this way, then these two lines must be equal to each other, and between that and the radius we're going to get 90 degrees. That's the rule we've just learnt before, okay? The tangent meets a radius at the circumference, we get a right angle. So that can be useful. What are the values of angles A and B? Well, remember what we've got here, from here to here and here to here, they're the same length. So that means that the green triangle that I'm about to draw is an isosceles triangle, which means angle A is going to be 180 minus 50 over 2, which is 130 over 2, which is 65 degrees. Okay, so we know that's 65 degrees, and we know that is 65 degrees, which means we can know that B is 25 degrees. Why? Because we know this must be a right angle, because a radius meeting a tangent makes 90 degrees. Okay, would be the same as this. We can know that that is also 25 degrees, which means you could then also find this if you were asked. Okay, right, last one. This is the tricky one. Okay, this rule is called alternate segment theory. Okay, and it simply says if we have a cyclic triangle, so all three corners need to be touching the circumference of the circle, meeting a tangent at the circumference, okay, then this angle must be the same as this angle. And it would also be true that this angle would be the same as this angle. So let's have a look at a little question here. Work out angles A, B and C and justify your answers. Okay, so what I know is that according to alternate segment theorem, here is a tangent meeting a cyclic triangle, okay, at the circumference. Now what does that tell me? That tells me that angle C is the same as 13. So I know C. C is equal to 13 degrees because of alternate segment theory. What else do I need to know? I can also see I've got a different triangle here. Okay, is meeting a tangent at the circumference. So it means this angle here is the same as A. So I know A is equal to 55 degrees. So all I've got to do is find B. Well, very easy. B is going to be 35 degrees. Why? Because this is a right angle. Okay, because you've got a radius meeting a tangent makes a 90-degree angle. Okay, so we need to be able to combine all of these rules. You need to look for isosceles triangles. You need to use all the basic rules of angles as well. Okay. Now, this is a nice little question. It combines what you were learning last week with similarity, with circle theorems, and a bit of Pythagoras. Okay, and this is a very, very IGCSE style question where they're bringing in lots of different topics together. Okay, now so we're going to use circle theorems to just show something here. I can basically know that this angle here is the same as this angle here. How do I know? It's a bow tie. So angles from the same chord are equal. I also know that this angle here is the same as that angle for the same reason. And I also know that this angle here is the same as this angle here because they're vertically opposite. So what do we have here? We have similar triangles, okay? So let's split the similar triangles up. So we've used circle theorems, 1, 1, 2, 1, 2, 3, to show that the triangles are similar. So that is 3, that is 5. Let's draw the other triangle. 1, 2, 3, 1, 1, 2. We know that 1 and 1, 2, that has a distance of 10, and that one is 8. Okay, so now we can try and find which sides correspond to each other. Well, I know this side corresponds to this side, so I can clearly see that the scale factor is 2, and this side corresponds with this side, therefore this length is equal to 4, and I can see that this side corresponds with this side, and therefore this length is equal to 6. So we're actually asked to find out what this angle here is. Well, now another little piece of math that you should know. You ought to know that an 6, 8, 10 triangle is a Pythagorean triplet. Pythagorean triplet. I expect you to know the basic ones. 3, 4, 5, 6, 8, 10, 5, 12, and 13. I would expect you to know those Pythagorean triplets. That is to say, 6 squared plus 8 squared equals 10 squared. Okay, 36 plus 64 equals 100. So if it's a Pythagorean triplet, what does that mean? It means, by definition, this must be a right-angled triangle. So that angle is 90 degrees, okay? So I can envisage that circle theorems questions might be combined with similarity questions, whereby you have to use your circle theorems to prove that two triangles are similar to each other. And then once you know the two triangles are similar, you can answer questions about them. Okay, I hope that makes sense.